All right, looking at problem 4-58. It says Annie was going to use the elimination method to solve the system below. She was ready to add the equations, because that's what we normally do, to eliminate the x terms when she noticed a problem. Both x terms are positive already. So if I were to add these together, I would have gotten, let's see, 4x plus 10y equals 18. The point is to eliminate with the elimination method, to get rid of one of these variables. So if I just add them together how they are, it's not going to get rid of one of the letters. So figure out something you could do that would allow you to add the value of the second equation to the first equation and eliminate the x terms. We still want to add the value, but we need to do something to one of these equations, or possibly both, to make the x's still be eliminated or canceled out. So solve the system and check your solution. So something that we can do, right, what we want to change is change one of these x's into being a negative 2x instead of positive 2x. So something we can do is multiply one of the equations by a negative 1. So I'm going to multiply one equation by negative 1. And I need to do this to every term in the equation I choose. So I need to multiply everything by negative 1 in that one equation only. If I multiply both equations by negative 1, then they would both be a negative 2x and we'd be in the same problem. They would not be eliminated. Okay? So I'm going to take this bottom equation and multiply everything there by a negative 2. So 2x times negative 1 right here. 2x times negative 1 will be negative 2x. 3y times negative 1 will be negative 3y. And 5 times negative 1 will be negative 5. Okay, so I just changed the bottom equation. I multiplied every term, each of these three terms, by a negative 1. Now I'm just going to copy this first equation underneath this one. Okay, could be written on the top, doesn't matter. And now, if I add my equations together, my x's, I have a negative 2x plus 2x, those go away. Okay, so that was the goal, is to eliminate one of the letters. So we did that by multiplying each term by a negative 1, because we still want to add the values together. We still want to add the equations. All right. Next, we're going to keep adding. Negative 3 plus positive 7 gives me a positive 4y. And I have negative 5 plus 13 will give me a positive 8. Now I solve this as normal. I'm going to divide by 4, and I got y equals 2. That's one of my values for this problem. Okay. Again, we need to find the x. There was an x and a y in both original equations, so I need to find x and y values. So to find x, I'm going to take this y equals 2 and plug it in. Let's plug it into maybe this first equation up here. Okay. Either one will get you the same result. 2x plus 7 times y, which I know y is worth 2, equals 13. So I just took this first equation right here and changed the y to say a 2 instead of y. Okay, so I'm going to multiply these together. 2x plus 14 equals 13. And I'm going to subtract 14 to get rid of the x, to get rid of it on the x side. So I'll get a negative 1, and I'm going to divide by 2. So I get x equals negative 1/2. Okay, so those are both of my solutions. There, x equals negative 1/2 and y equals 2. And you should check your answer by plugging it into both equations here. So on your paper, I'd like you to check your answer by plugging it in the x of negative 1/2 right here, plug in y of 2 in here, and see, does that equal 13? Same thing with this second equation. Replace x with negative 1/2 and multiply it. Replace y with a 2 and multiply it. Does that really equal 5? Make sure all of this stuff is written on your paper too.